In this video, we're going to cover the final learning objective for the core of Unit 8. So far, we've created our inverses ourselves, whether from a table, a graph, an expression, all these different things. We've given something and we have to find the inverse. But now in this learning objective, we're going to be given two different functions. We just say, are these things inverses of each other? So how do we do that? Well, first we need to kind of figure out what should happen if I combine a function and its inverse. So let's just say I'm going to take my original function, I'm going to put in a, and then I would get out b. And now I'm going to take that answer and put it into my inverse. I'm going to take this b and put it into my inverse, and that gives me out a. So if I kind of just follow this chain, then I started at a, and I ended at a. And that makes sense because my inverse just does the reverse of the original. So if I do the original function, the inverse just sends me right back to where I started. So if two functions are inverses, when you do one and then the other, you just always get back to where you started. All right, so the way this is going to work when we're actually doing it with expressions, is what we're going to do is we're going to put one entire function into the other. And we'll kind of see what that means in a second. But basically what that means is we're doing one of the functions first and then the other one second. And if that actually works, that they're actually inverses, you just get back to where you started. Where I started by plugging in an x, so it should simplify down to the same thing I started with just an x. All right, so we'll see what this means in an example, but the basic idea is we want an expression to simplify down to just x. The fancy word for this process is known as composition of functions. We're not going to do the full composition of functions in this video, but it will be covered in a bonus objective. All right, so now we want to see, are these functions inverses? All right, so the way we figure out if functions are inverses is we're going to take one of our expressions and we're going to put it in for the x in the other expression. So this whole thing is going in there. All right, so I'm going to have the cube root, doesn't change, but instead of that single x, I'm going to put x cubed plus 4. And now I did that, now I have the minus 4. All right, so you can see that this x in this red box here is getting replaced with that red box, which is all of g of x. All right, so that's our first step. And then we just want to simplify as much as possible and see kind of what cancels out. The first thing I see is I have this plus 4 and this minus 4. Those are opposite, so they're just going to cancel out. And then I have the cube root of x cubed. All right, the cube root is literally defined to be the opposite of a cube, so those things are also going to cancel out. And all that's left is just my x. All right, so are these things inverses? I put one inside of the other, and I got down to just x, so the answer should be yes. All right, they are inverses of each other. And you may be wondering, what if I did it the other way? Well, let's do it the other way. Now I'm going to take all of f and put it in for the x in g. All right, so instead of x cubed, I'm going to have this whole expression being cubed, and then plus 4. All right, so that yellow box is going into g of x. Here, the order is going to be a little bit different, but the same ideas are going to happen. I have this cube being applied to this cube root. Like we just saw, those are opposites of each other. So the cube root and the cube cancel, and I just get the thing on the inside. Now the minus 4 and the plus 4 cancel, and I just get x. All right, so it doesn't matter which order you do it in. When you put one inside of the other, it simplifies to just x, and that means that they are inverses of each other. All right, let's do another example. All right, so again, it doesn't matter which one I do. So let's just say I'm going to put all of g in for the x in f. All right, so the 4 is not going to change, but that x is going to get replaced by 3x plus 4 minus 3. And now we just want to follow the kind of algebra principles of simplification. First thing you do is distribute 12x plus 16 minus 3. I can combine the two like terms at the end, 12x plus 13. And there's nothing else I can do to simplify here. I can't combine 12x and 13. There's no other terms. All right, so are these things inverses of each other? The answer is no. All right, why not? Because when I do one and the other, I get something more complicated than just x. I didn't get back to where I started with. All right, I started at x, but I didn't get back there, so these things could not be inverses of each other. So here's a problem for you to try on your own. Go ahead and determine if these two functions are inverses. And the answer you should get is that they are inverse of each other. I've shown two different ways you could do this. So you're just putting one function inside the other. So I could take the whole f function and put it in for the x in g. All right, that's written out in red. Or you could take the whole g function and put it in for the x in f. That's written out in yellow. All right, it doesn't matter which one you choose. All right, but when you simplify, all right, remember to distribute. Everything cancels out and you just get left with that x at the end. And if it simplifies down to just x, they are inverses. All right, for this skill check, for this learning objective, you're gonna have to do a skill check. And for the skill check, you're just gonna get two pairs of functions and you have to determine if they are inverses of each other. All right, so you have to go through that whole process. You can't just guess yes or no. You're not gonna get any credit if you just guess yes or no. All right, to go through the process of putting one function inside of the other and simplifying.